Yes.
See my cursor? You see my mouse where I'm pointing? Okay.
Yep.
One
There's some
hypothesis
delay.
would be,
Give me 1 second. There's like a delay. Try it again. Try it again.
okay, can you hear me now?
Yes.
Is it good?
Yep.
Okay. So I think one hypothesis would be, if I have and I have another bend, and if the center line between the bends is less than that much, I'm not going to be able to make it without getting outside of the robot. So,
I'm still losing you. I don't know why.
3-link robot might not be able to make it. That could be one hypothesis. And then the other hypothesis could be, if I have only one bend, how far deep can I go in the trachea?
I guess we need to.
And then
We need to do them all, like multiple tries.
yeah. And then the second one would be, if you have two bends, if you have only one bend like this one, how much of an angle can you go? Can you go all the way to 10 degrees, 50, 70, 90, 120, 130? How much of a bend angle can you do without getting outside of the walls of the trachea? I think these would be three parts to the hypothesis. So how would you call that? You could say how far and how many bends it can reach to, consecutive bends, and what's the maximum angle it can do. Maybe something like that.
So angle, length, and like reach.
Angle, reach, and consecutive angles in a yeah. So what is the maximum angle it can do without getting outside of the airway? How many angles, consecutive angles it can do, one after the other, without getting outside, and then how far down in the trachea it can go.
Yep, I I have the notes. Okay. And also can be, okay. Do you wanna highlight the size or the diameter of the robot, like whether or not it can fit through the entire tubes or not, or whether or not right at the end it doesn't fit no more. So like when it becomes very thin, so maybe because of the size of the robot, it cannot go to the bottom left and bottom right. Do you get what I mean?
I do. Yeah, we can say something to that too.
Like fitting, something like that. Does it?
And then we want to also see the effect of the length of each section on how flexible it is.
Say that again.
The length of each section of the robot on how flexible it is. The length. So here in the paper, what he's asking us, I just went to the assignment again. The robot is 3-section robot with each section 10 millimeters long. No trunk is attached to the 3-section. So only 3-section, 3-car train. So basically 10 millimeters long, but he didn't specify the diameter. So one variable will be the diameter of the links.
But if he's saying it's three links, each one having 10 millimeters.
10 millimeters length. The length is 10 millimeters.
So it means that in total it's 30 millimeters.
Correct. But you know what?
Then
I think, hey, Alfredo, I think I got an idea for innovation here. You know what?
what?
The idea for innovation that I have is we are assuming all along that the diameter of each of the links is the same. What if the diameter of the first link was a certain value and the other 2 links were smaller, or maybe the first and the second were the same and the third was thinner in diameter? What would that do to the ability of it to reach? And our hypothesis could be, if we use a 3-link robot, that each of the links is the same diameter, which has always been the situation, then it limits it a little bit and we show the limitation. But if we change the diameter on the last link, and that will be our innovation, that there wasn't a robot that was tried before with the last diameter changed, then this allows us to do more with it. You understand where I'm going with this?
I understand. However, we need to leave some space for handling a camera at the end effector.
What is the, yes.
So I don't know, I guess it makes sense, but we need to consider that the end effector will have some sort of camera to look at the stuff.
Is it a camera? Let's read the article, because I thought it is just a needle, or it's something that will pull a biopsy.
So
let's look at the Dupuc article.
I think on my conversation before you arrived, So basically he emphasized like, can you get there, yes or no? So that was the question he made to me like multiple times. That was our focus. It's whether or not we can get there, yes or no.
And that is exactly my point. We have to figure out what diameter we'll use, so the effect of the different diameters, what is the smallest diameter we can go, and would it make a difference if the end effector, the tip, was of a smaller diameter than the rest of the robot. And would that make us get there? So basically what I'm thinking, when you say can you get there or not? Well, the way I came up with this idea, if you look at the shape of the trachea, it starts thick and then it narrows down. So if I can make the robot to match that profile, I might, and this is a hypothesis at this point, the paper should be able to test it. And we can say, if we reduce the diameter of the last link, or maybe the paper shows us it's the second link that has the diameter needs to be changed because the one curvature, I don't know, then we would be able to get there, but with the other way, we were not able to get there. You know what I'm thinking?
Yeah, like a comparison.
Exactly. Comparison of one robot that has, because the idea also is that the section of the robot that is near the base will need to have a pull wire for the first, second, and third section go through it. And it might need, if we're going to use a camera or some sort of a suction mechanism, has that. So it has 3 or 4 things going through that diameter. But that very end effector tip in there has only one pull wire going through it. So you might be able to justify making that narrower. 1 or 2, like the pull, and then, so 2 instead of 4, basically. And the one for the pulling the biopsy sample and the one for the pulling itself.
Oh, there's a robot. There's another robot that has dual thread. Kind of like goes. It is one, and then it turns into 2. Have you seen it? Like there's a multi-section robot on one of these papers that is kind of like like a hand.
Can you share your
so
screen?
Maybe, let me look for it. It's in one of the papers. Let me.
You're saying it's 1 and then it turns into 2?
Yeah.
But how you're going to do that with 3 sections only?
Oh, right. We're forced to use one type of robot. Yeah. I'm sorry.
Yeah, that's
I was
taking
changing the assignment. Sorry about that.
Yeah. So I think let's do this. Let's throw around a few hypotheses on the discussion group and then agree on one and send it to him tomorrow. But I personally like the idea of trying the making the last one narrower and see what that does.
Yeah.
Because that's innovation right there. I mean, if we do that and it works, that's innovation. Because I don't think
Yeah, we
I've
don't.
seen any of the papers like that. It's not going.
All right, so I have a couple of things here. So we said the max angle probably per section, right?
Yes.
Probably, okay. So max angle per section, consecutive angles capability, reach, or the how far or the depth that the robot can reach, and then does the robot fit across the entire trachea, length of each section of the robot might so you said this one, like what will be the desired length of each section so that it can reach, right?
Yeah, but he said use a 10 millimeter length.
Got it.
But we can look at the effect of having different lengths, what the effect of each length would do. If you make the first section longer, what does that do? Second section longer, third section, and then the last one will be effect on diameter, varying the diameter, and then the effect of having the end effector diameter slightly smaller than the rest of the diameter.
At the end.
Yeah.
All right, so that's all the ones that I wrote. Any other one?
I think that's what we have. I mean, we just need to formulate it. If you want to just put them as points in the discussion, and then I will try to write a hypothesis and share it. I'll probably share it with you in the morning sometime, and then you can share your hypothesis too, and then maybe send it to him before our meeting tomorrow. You can combine them or send one, or I mean, I'm okay. I trust you can. You look at them and see, and I'm okay. I mean, we're a team, so we're working together.
I'm gonna put it right now. Give me 1 second.
Alfredo,
You
if you
see that
don't
I
need,
upload?
you put that in
You want
there.
me
Okay.
to? I already have the video here. So I'm gonna type here the topics that we discussed. All right. I'm gonna
Okay.
stop recording now.
Okay, and then did you share the video with him? Put the link for the video of our earlier meeting on the synopsis?
On the synopsis, no, we didn't talk about that. I just said that we would meet on that tomorrow.
But did you share did you post to YouTube of the synopsis discussion?
No, I haven't. I'm gonna do that before going to sleep today.
Okay. So are
Let
you
me stop
okay?
recording.